All right, we'll be looking at our, it's actually week 17 math review, 7th grade week 17 math review. We'll be looking at days 1 and 2 in this video. In day 1, this chart we completed in class. I'm going to cover just a couple of them as a reminder. 7%. Well, percent means per 100. So 7% is the same as 7 per 100. Per, we can read the divide bar as per. 7 per 100. The decimal version, well, to convert a percent to a decimal, we simply move the decimal 2 places to the left. So 7% is 0.07. We read this as 7 hundredths. This is the 10th place, this is the 100th place. This is 7 hundredths. And I would read this likewise, 7 hundredths. 7% is equal to 0.07 is equal to 7 over 100. Okay, solve the equations. These two are inequalities. They have this a greater than and this a less than in it. This an equation. So we're going to solve each of these statements here. So we're solving for x. We want to get the x by itself. First, we can combine these like terms. 15 minus 6, that's 9. So negative 3x remains the same on the left. Less than we preserve. 15 minus 6 is 9. Lastly, we want to get the x by itself. Well, this is negative 3 times x, so we will divide by negative 3. Whatever we do to one side, we must do to the other. Dividing negative 3 by negative 3 leaves x. This line is just for separation. Dividing 9 by negative 3 is coincidentally negative 3, because negative 3 times negative 3 is a positive 9. Well, special case, when we divide or multiply by a negative number, we change the direction of the inequality. So my answer is x is greater than negative 3. I could convert that, I could express this inequality on a number line. So I draw my number line. I'm going to center 0, and then I'm going to put two numbers on the right and the left. Here's positive 3, and here's negative 3. This indicates that I know the positives are on the right and the negatives are on the left. I want values of x greater than negative 3, so I want an empty circle above negative 3 because we are not equal to negative 3, and I want greater than that, so I shade in this direction. In this number line, I've shaded all values such that x is greater than negative 3. We can't be equal to negative 3, that's why we have this open point, but we can be any of these values. 0 satisfies that inequality, 3 satisfies that inequality, but negative 6 would not. Alright, I'm going to do one like number 2 here. Like number 2. I'm calling this problem here number 2. So I'm going to change this to a negative 4 plus 10x equals negative 60. Okay, well, we want to get the x by itself. So we will first eliminate this negative 4. Look in front of it. Since it's a negative 4, we want to undo that by adding 4. This is the additive inverse. Whatever we do to one side, we do to the other. Negative 4 and positive 4 add to 0, leaving only 10x. Over here we have negative 60 plus 4. Remember, when adding, if the signs are different, we simply subtract the numbers, the absolute value of the numbers. That is 60 minus 4. Well, 60 minus 4 is 56. We must consider, what should the sign be? Well, we have 60 negatives and 4 positives, so our result will be negative. Whatever number has the greater absolute value keeps our sign. That is, we have many more negatives than positives, so it makes sense that our result would be negative. Lastly, I want to solve for x, so I divide by 10 on both sides. X divides x, 10 divides 10 to leave x. Negative 56 divided 10 is a negative 5.6. Dividing by 10 is like taking 10%. We simply move the decimal one time to the left. X is a negative 5.6. Use this information and see if you can solve number 2. I want you to omit number 3 here. Omit. Alright. Going on down, we're adding or subtracting. We have some mixed numbers here. I'm going to look at our first one. We have 2 1/4 plus a negative 3 1/5. I'm going to show this by finding our improper fraction first. So 2 times 4 is 8, plus 1 is 9. 2 1/4 is 9/4, plus a negative. 3 times 5 is 15, and 1 is 16. This is a negative 16 over 5. So we have 9/4 plus negative 16 over 5. Well, remember, when adding or subtracting, we must have a common denominator. So with 4 and 5, the common denominator is 20. I need to change these numbers so that they're both over 20. 20 in both denominators. So, question, 4 times what gives 20? Well, 4 times 5. Thus, I must multiply the numerator by 5 as well. So, 9 times 5 is 45. 9 over 4 is equivalent to 45 over 20. 5 times what gives 20? 5 times 4. Thus, I will multiply the numerator times 4 as well. Negative 16 times 4 is a negative 64. Negative 16 over 5 is equivalent to negative 64 over 20. Now we are ready to sum. The denominator will stay the same. As before, whenever the signs are different and we're adding, we will subtract the numbers. 64 minus 45 is a 19. Since there are more negatives than positives, this result is negative. Negative 19 over 20 is very close to a negative 1. We want to see, is this reasonable? Well, our initial problem was 2 1/4. That's about 2. Plus a negative 3 1/5. That's about negative 3. Well, positive 2 plus negative 3 is negative 1. So indeed, this negative 19 over 20, it looks reasonable. Remember, when we have a subtraction, we will keep, change. So to say, 2 7/8 minus 1 1/4 is the same as negative 2 7/8 plus a negative 1 1/4. Make that change first. Right, you should be able to handle the rest of these problems. For this last one, remember that similar means proportional. Similar means proportional. The sides are proportional. That is, there's some multiplier from one to the other. So if we have one that's 7 by 4, you could double both sides or triple both sides. So consider what the next rectangle would look like. All right, day 2. We have negative. I'm going to do this one. This one is probably the hardest one in this set. I'm going to do one like number 3. Like number 3. All right, with this information, you should be able to very easily do number 3 here. Let's say we had 20 minus 5x equals 41. All right, we want to get this x by itself. So I will first undo this other term. It is a positive, look in front, it's a positive 20, so I'm going to subtract 20, or said another way, add a negative 20. Whatever I do to one side, I do to the other. Okay, well 20 subtracts 20 to leave, here you see it's a subtract 5x, but in this context we will write a negation, negative 5x. All right. You see, we took away the 20s, but see clearly there we still have that operator left, the subtraction. Well, when we write it by itself here, we write it as a negation, negative 5x, equals 41 minus 20 is a 21. All right, solving for x, we will need to divide by our coefficient, negative 5. Negative 5 divides negative 5 to leave x. 5 goes into 21 4 times with 1 left over. I'll express the leftover over the denominator, and it's a negative. Negative 4 1/5. That is our solution. X isn't equal to negative 4 1/5. With that, you should be able to readily do this one, and I think you'll be okay on these other ones too. Okay. Down here, Jill's going to Utah. It says 1 inch is 615 miles. If she needs to travel 512 miles, how many inches? Well, I hope you see this is going to be a division. Since 1 inch is 65 miles, if we're doing 512 miles, we would divide 65 into 512. Examine 65 into 512 in this case. When we have our scale problems, they're either going to be a multiply or divide. You just need to figure out which one it's going to be. Okay. Trent goes 420 miles in 5 hours on his video game. At this rate, how long will it take him to go 500 miles? Well, a rate problem, we can use a proportion. I'm going to put my miles over hours. So he goes 420 miles in 5 hours. 420 over 5. Miles over hours. How long will it take? We're looking for hours. We don't know the hours. I can put X down here. I'm going to put H to stand for hours. 500 miles. All right. Here we have our proportion, and now we can cross, multiply, and solve. I think you know how to do this. We could reduce here to make this a little bit easier. You could see how many times 5 goes into 420 and reduce this fraction. It would make our cross multiplication a little bit easier. I hope you can see it's not going to be much more than 5. 420 goes to 5. In multiplication, it's not going to be too much. It's going to be slightly over 1. So it's going to be 5 times slightly more than 1. It likely won't even be 6 hours. So we're looking at, it's going to be a number close to 6 here for H. All right. See if you can answer the rest of these problems.